So in this lesson, we are going to solve inequalities again using inverse operations, and we're going to provide evidence of the solution set. So basically evidence that our solution is true. Our solutions are true, really. So we have 3 times the number plus x divided by 8 is all less than 2. So let's start with this. We had x, we multiplied by 3, we added 4, we divided by 8, and we got something that was less than 2. So if we use inverse operations going backwards, instead of divide by 8, we're going to multiply by 8. This part y'all are familiar with. Remember both sides. So 3x plus 4 is less than 2 times 8, which is 16. Now, instead of adding 4, we subtract 4. 3x is less than 12 because 16 minus 4 is 12. Lastly, we divide by 3, so we can get 1x, and we divide by 3 here. Now, one mistake I see that people do is sometimes they like to put the x also. Do not put this x, because that means the x's will become 1, but we need an x. We need an x down here, so we can't do that. We're trying to isolate x. We're trying to get x alone. We're not trying to get rid of it. So just divide by 3, we get x is less than 4. So 4, 3, that's 5. So can x be 4? No, but it can be any number less than 4 until we get really close to 4. So in order for the inequality, remember this is an inequality, not an equation, not an equation, it's an inequality. In order for this inequality, it's close enough, right? Inequality to be true. Remember on the work, you don't have to write this entire statement out. You just have to write the parts that you fill in or circle. So in this one, in order for the inequality to be true, the variable must be less than 4. So less than 4. If the variable is not, then the equation will be false. Probably should be a comma there or something. So let's prove that the variable must be less than 4. So I'm going to go here, and I'm going to write it out. It's 3x plus 4 over 8 less than 2. So x, let's make x is less than 4, right? So let's make x equal to 3. So instead of 3 times x, we write 3 times 3 plus 4 over 8 less than 2. Should be less than 2. 3 times 3 is 9. Sorry, I'm writing kind of in a weird order. 9 plus 4 over 8. So 9 plus 4 is 13. And 13 over 8 should be less than, I don't know why I put 12, should be less than 2. I will go ahead and I guess I could do this one. So 8 goes in there 1 time. There are 5 more, so that's 0.675. Good. Is less than 2. So 1 in 675 hundredths is in fact less than 2. Now let's prove that if we don't choose a number less than 4, that this is not true. So I'm going to pick a number that's not less than 4. So a number that's not less than 4 is 5. So let's use 5. So 3 times 5 plus 4 over 8 less than 2. So 3 times 5 is 15. 15 plus 4 over 8 should be less than 2. 15 plus 4 is 9. Oops, almost put an equal sign. So 9 over 8 is less than 2. So 8 goes into 9 one time. There's 1 left over. Wait, that's 19. I made a mistake. 15 plus 4 is 19. Okay, better, because I was like, something's wrong. So 19 divided by 8. 8 goes into 19 twice. That's 16. That means there's 3 left over. So 0.375 is less than 2. Is 2 and 375 hundredths less than 2? No, it's in fact bigger. This is wrong. Now, one last thing before we go on to the next example. A lot of you may have wanted to put 4. A lot of you may have thought, why don't I just make x equal to 4? And some of you would use it as a shortcut, right? Or try to use it as a shortcut so that you don't have to think. You just automatically use that one. But remember, x has to be less than 4. X has to be less than 4. You can't choose 4. You can't choose 4. It would have to have the equal sign, okay? Don't choose 4. Let's look at the next example. What I'm going to do with this example, though, is I'm going to change. Okay, I'm just going to leave it. I'm going to leave it. I know why I put it like that. So negative x over 4 plus 3 is less than 2. So what I'm going to do, if you ever see anything like this, I'm just going to rewrite this. See how the negatives on the side? I'm just going to bring it up. Negative x over 4 plus 3 is less than 2. Don't make the x negative and the 4 negative. You can't do that, because a negative over negative would be a positive. And remember, this is negative. Only one of them can be a negative. Only one of these can be a negative. I made the x. Okay, so we had x. We multiplied by that invisible negative 1. We divided by 4. And we added 3. So I'm going to put that invisible 1 there. Remember that invisible 1. So x times negative 1 divided by 4 plus 3 is less than 2. So we got something less than 2. Let's go backwards. Instead of adding 3, we'll subtract 3. Negative 1x over 4 is less than 2 minus 3 is negative 1. Now I'm going to multiply by 4 instead of dividing. So multiply by 4. So we get negative 1x is less than a negative times a positive is a negative 4. I'm trying to make that look a little bit better. Okay. And then now we are going to divide by this negative 1. But remember, when you multiply or divide by this negative right here, we're going to flip. We divided by negative 1, divided by negative 1. That means we flip it, okay? So x, instead of putting less, I'm going to put greater. Negative divided by negative is a positive 4. Ooh, I did not mean for that to happen, but that's handy. So 4, 5, 3. Can x be 4? Yes. So no, it can't be. It doesn't say equal. So I'm going to leave it open, but it can be greater. Cool. So in order for the inequality to be true, the variable must be greater than 4. Oh, this is greater or equal to. Greater than 4. If the variable is not, then the inequality will be false. So let's go ahead and put in remember, x has to be bigger than 4. So I'm pick 6, I don't know. And so 6 over 4, don't forget the negative, plus 3 should be less than 2. So I'm just going to do this division first. You can put it up here, this negative. You can do it like we did here, but I'm just going to do the division first. 6 divided by 2 is 1.5. So negative. Plus 3 should be less than 2. And 3 minus 1.5, or 1.5, is 1.5. 1.5 again. And is that less than 2? Why, yes, it is. Let's try something that shouldn't work, a non-solution. So 6 was a solution, 7 was a solution, 8 is a solution, 4.0001 was a solution. Any number bigger than 4. We can't choose 4 unless it says equal to, okay? We can't choose 4 unless it says equal to. And let's pick one that's not a solution. So what's not greater than 4? I'm going to pick 1, I guess. So 1, oops, I'll put it on the side like in the problem, just so y'all can see that it's the same. So 1 divided by 4 is 0 and 25 hundredths. 1/4 is 0 and 1/25 hundredths. 0 and 25 hundredths. Plus 3 should not be less than 2. So 3 minus 0 and 25 hundredths is 2 and 75 hundredths, which is supposed to be less than 2, or not supposed to be, but you know what I'm saying. This doesn't work because it is not less than 2. This is bad. This is not true. All right, thank you.